Example 2, Part A. If you deposit $100 at the end of each of the next 15 years, earning 10% per year, what would your balance be at the end of the 15 years? Part B. If you wanted to be able to withdraw $100 at the end of each of the next 15 years, earning 10% per year, what size one-time deposit would you have to make today? Okay. So we'll start by drawing the timeline. So we have a lot of words, but it looks like this. So you're depositing $100 at the end of each of the next 15 years. So it looks like this. So obviously this is a multiple cash flow problem, and the first step is to always recognize what type of cash flow pattern you're dealing with so that you'll be able to apply the correct formula. Okay, so we have the same magnitude, $100, occurring at regular intervals every single year up until year 15 for a finite period of time. So this is an annuity. Okay, and it asks, what will your balance be at the end of the 15 years? So we want to find the future value as of year 15. Okay, and it says we can earn a rate of return of 10%. Okay, so we have an annuity, we're given the R, we're given the number of years, so we can find the future value of this annuity. So I'll use the future value of an annuity formula. Looks like this. Right? We have cash flow times 1 plus R to the n minus 1 over R. So we're calculating the future value of this annuity as of year 15, and the cash flow, the magnitude of the cash flow, is $100 every year. The R is 10%. The N is 15. Okay. Minus 1 over 0.1. So we know that the N is 15 because we have a 15-year annuity. Okay. So based on this cash flow format, we know that the contract was signed here at time 0. Contract signed at time 0. And the annuity ends in 15 years. So this is a 15-year annuity. Okay. That's why N is 15. Okay. So if you do the calculation, you'll have $3,177.25 in your account at the end of 15 years. Okay. Okay. So part B says, if you wanted to be able to withdraw $100 at the end of each of the next 15 years, earning 10%, what size one-time deposit would you have to make today? Okay. So the setting is slightly different, but the timeline remains the same. Okay, so we can just I'll actually draw the same timeline. So we have the same 15-year period. But instead of depositing $100, we want to be able to withdraw $100. Okay. R is still 10%. It says, what size one-time deposit would you have to make today? Okay. So if you want to do this, how much do you have to put in today at time 0 to be able to withdraw $100 every year for the next 15 years? Okay. So again, it's the same thing. We have an annuity, a 15-year annuity. Okay, and we're trying to calculate the equivalent value as of today, basically. So we're trying to get the present value of this annuity as of time 0. Okay? So I'll use the precise formula. PVA as of time t is equal to cash flow t plus 1 over r. Again, the subscripts are just time indicators. Okay? So we're just keeping track of time. You don't do anything in terms of the calculation, when it comes to subscripts. So this is the formula. Okay? So here, again, how the formula works is we're always going to look at the first cash flow of that particular cash flow pattern. Here we have an annuity, right? And the first cash flow is this one. It occurs in time 1. Okay? So that just means, I'll just use purple. So the first cash flow occurs in time 1, which means t plus 1 is 1. Okay, so I'll just write it here. T plus 1 is 1. Okay, so the PVA that we're going to calculate is, I'll just use this. PVA that we're going to calculate is 1 period prior to the first cash flow. Okay. So PVA T will be 0. So since t plus 1 is 1, you can solve for t, right? T is just 0 if you subtract 1 on both sides. So this is just showing you, I'm just showing you how the formula works. Okay, so yeah, I'll just leave it like that. So we're going to plug the numbers in. Here, the first cash flow of the annuity occurs in time 1, so we can get the PVA as of time 0 right away. Okay, so the magnitude of the cash flow is $100. R is still 10%. And we're going to 1.1 to the 15th power. So just like before, N is 15. This is a 15-year annuity whose contract was signed in time 0. Okay? So this gives us 760.61. So this just means if you have an account that gives you a 10% return, okay? If you have an account that gives you a 10% return, if you put in $760.61 into your account at time 0, you'll be able to withdraw $100 every year for the next 15 years. Okay? And another way to do part B is as follows. Okay? So we already calculated, let me highlight this. We already calculated this number, 3177.25. That was the value of this annuity as of year 15, right? And we're trying to calculate the present value of the annuity as of time 0. The same annuity, okay? The same annuity, the $100 annuity. Trying to calculate as of time 0. Okay? So we could use the PVA formula like we did here, or we could draw another timeline. I'll just say B-2. I'll draw another timeline. 0 and 15. So I'm going to use this number that we already calculated down here. So 25. Okay. And then using this value, I'll calculate the equivalent value as of time 0. That is how do we calculate the PV based on this timeline? we can use the PV formula, which is PV equals future value over 1 plus R to the nth power. The future value is 3177.25. The R is still 10%, and the N is also 15 years. Okay, we're discounting this value back to time 0, right? 15 periods. And if you do the calculation, you'll see that you'll get the same number, okay, as we did, using the PVA formula. Okay? So this is conceptually important. Okay? So to briefly recap, what we did was, in example 2a, we noticed that this was an annuity, a 15-year annuity, and we calculated the future value of this annuity in year 15. It just means getting $100 every year for the next 15 years is basically equal in value to getting 3177.25 in 15 years. That's just time value of money. Okay, so they're equal. And depositing in part B, depositing $760.61 at time 0 is the same thing as getting or paying $100 every year for the next 15 years in terms of value. Okay, so these are all equal. That's why if you just use the future value in year 15 and then discount it back 15 years, you'll still get the same answer for part B. Okay.